Okay, so this is another problem for determining continuity, finding discontinuities for a particular function. This one we have the natural log of 2x over x minus 7. What we really need to remember here is that for natural logs, natural log of 0 is undefined. That's important for this problem. And also we of course remember that can't divide by 0, so immediately we can see that if I plug 7 in here, I've got a 0 in the denominator. Can't divide by 0, so we're definitely going to have a discontinuity there. Function is not defined, that means we have a discontinuity. And also notice that if we plug in 0, we're going to have a problem as well, because 0 divided by negative 7 is 0, and that'll give us the natural log of 0. So can't have that either, so that's also going to be a discontinuity because it's undefined there. So the rest of this problem also asks to find limits. So to do that, we can make a table of values. For example, if I want to find the limit as x approaches 0, the way I'm going to do that is find the limit as we approach from the left and the right. So probably the best way to do that in this case is to make a table of values. So we'll pick values of x that are slightly less than 0. So we'll go negative 0.5, we'll say negative 0.1, negative 0.01. I'm going to go a little bit closer to 0 on this one because this is a slow growing function, so I want to make sure we see exactly what's happening. When I plug in 0, we know what's going to happen there. Nothing. There's no output at 0. And we'll put 0.001, 0.1, 1, and 0.5. So I've entered this function in my calculator, so I can fill out this table fairly quickly. If we plug in negative 0.5, we're going to get negative 2.015. Plug in negative 0.1, negative 3.57, negative 0.1, negative 5.86. Plug in negative 0.001, we get negative 8.16. I think that we can hopefully see that as we get closer and closer to 0, these y values are getting larger and larger in the negative direction. They're not approaching any particular y value. When we go on the other side, we'll see something like this. So it's pretty similar, but not exactly the same. So now you've got negative 5.86, and then for negative 0.1, negative 3.54, and then finally negative 1.87. Okay, so the important thing to notice is that as we approach 0 from the right, the numbers are getting larger and larger in the negative direction. As we approach from the left, the same thing is happening. They're not approaching any particular value, so we say that this limit, in fact, I told you earlier that I was going to find the limits from the right and the left, but we just did both, so just get rid of that minus on there. Then from the table we can say that this limit doesn't exist. But if we wanted to be more specific about it, we can say that it's negative infinity. But either way, it doesn't exist. For the other limit, as we approach 7, we can kind of do the same thing. Just make a table of values. So now we're going to pick values of x that are close to 7, but not equal to 7. So we'll go, let's try 6.5, 6.9, 6.99, and we'll do the same thing. We'll go to 6.999. Put 7. We know we've got no output there. And then on the other side of 7, we'll go similar. 7.01, 7.01, 7.1, and 7.5. So if we put these values into the calculator now, I'm going to enter my new values, 6.5, 3.26, 6.9, 4.93, 6.99. And put in 6.99, we get 7.24. 6.999, we get 9.55. And then similar on the other side, we get 9.55 over here. 7.25. 4.96. And 3.4. Okay, so again, our conclusion based on the table is that these values of y are getting larger and larger the closer that I get to 7. So that means that the limit is going to not exist here as well. So we'll just say limit as x approaches 7 of this function does not exist. Or again, if we want to say, since the values of x in this case are both getting larger and larger, we can say that it's infinity or that it doesn't exist. I think in my math lab they probably want you to put the infinity on that one to get the correct answer. Anyway, hope that helps.